Black holes are fascinating phenomena that capture our imaginations much the same way they capture every particle within their reach. The massive gravitational pull of a black hole is so strong that not even light can escape it. But for centuries, black holes were just a concept, a mathematical theory based on Sir Isaac Newton's law of gravity. Today, however, we know that black holes do in fact exist. The first photo of one was taken in 2019, but there is still much to learn about these mysterious wonders of the universe and plenty of room for speculation.
It's funny that so many people think they know what a black hole is, but people's conceptions are often off. People think of a black hole as a very dense object, but a black hole is actually not an object at all. It's more like a place. It's a place in space-time where the curves are so strong that not even light can escape. And that phrase that we've heard a lot refers to something we call the event horizon. So the event horizon is really a region in space-time. If you were to go up to the event horizon, all you would see is a shadow, and there's nothing there. There's no matter there anymore. It's gone. So it's really not an object. It's more like a place.
That's Jenna Levin, a professor of physics and astronomy at Barnard College of Columbia University. She's also the author of Black Hole Survival Guide, a surprisingly accessible take on a daunting subject. She writes that 6 months after Albert Einstein published his theory of relativity in 1915, his friend Karl Schwarzschild used Einstein's theory to mathematically show that black holes exist.
It was an incredibly elegant solution, incredibly simple, actually, in this very complex mathematical theory. So Einstein himself did not discover black holes. They were discovered by his friend Karl Schwarzschild. Now, they weren't called black holes for many decades. 5 decades later, they earned the name. But it was just this kind of imagining. And what Schwarzschild did, he said, just imagine. I'm not going to ask how this is possible, but just imagine all the matter of, let's say, a star crushed to a point. And this is what the curved space-time would look like around that point. And Einstein thought the solution was very elegant. He was impressed at how quickly it had been obtained. He helped get it published, but he thinks that nature will protect us from their formation. I mean, after all, it's really hard to crush things. I can't crush my phone to a point. It would be impossible because matter resists. Right? It resists being crushed. So Einstein didn't believe they would form in nature. And it was a debate that went on for many years before we realized that nature had thought of a way to make black holes. And that was by killing off some very heavy stars.
Since then, we've learned that black holes are relatively small. For example, if our sun, which is 1.5 million kilometers across, were to collapse, the resulting black hole would be only about 6 kilometers across.
And so what people think of as these giant monsters looming in space, they're actually tiny. That's sort of their whole gestalt, that they're heavy, but they're small. You could fit a black hole the mass of the sun inside New York City. They're city-sized.
And yet, these teeny tiny objects are what hold together the billions of stars and planets that comprise a galaxy, like the pin at the center of a pinwheel. You can see the effect of the black hole at the center of our own Milky Way. However, not all galaxies have pinwheel shapes. The reasons behind this are yet another mystery scientists are trying to solve.
Nobody anticipated that. We started discovering supermassive black holes at the centers of galaxies and then walked away realizing, well, essentially every normal galaxy is going to have a supermassive black hole at its center. We see hundreds of billions of galaxies in the observable universe. That's hundreds of billions of supermassive black holes. And they provide some kind of mechanism, we believe, for sculpting the galaxies. So when the galaxies are forming, these black holes with their powerful jets and these magnetic storms that they create in the interior of galaxies sculpt how the galaxies form and regulate the nature of the galaxy. So part of our history of having this planetary system with this kind of ordinary yellow star and this habitable planet, part of our history is shaped by that black hole. We may well fall into that supermassive black hole one day.
Not that it's likely to happen anytime soon. It's more likely that this will occur billions of years from now. But let's imagine our sun suddenly collapsed and became a black hole today. Would Earth be immediately sucked into its black maw like water down a bathtub drain?
Our orbit would actually be fine. We wouldn't suddenly be sucked in. It's only when you get catastrophically close that you begin to notice that it becomes harder and harder to resist the infall.
However, let's imagine that you did somehow manage to fall into a black hole. What then?
Once you cross the event horizon, your continued fall is inevitable. There is nothing you can do to halt your decline. It's not as though you can hover safely on the interior of a black hole. You are driven towards the most dramatic region of curved space-time, which we sometimes call a singularity, where space-time is essentially infinitely curved. And then you are for sure pulverized and crushed to death and torn to shreds. And it's very dramatic. But whether that's your definite fate is something that even Sir Roger, in his paper in 1965, as soon as he proved this, he said, well, maybe singularities aren't real. Maybe with quantum mechanics they'll go away. So this continues to be a kind of debate about what's on the interior of a black hole.
There are many theories out there, but the fact is, no one knows for certain what happens to matter inside a black hole, especially at its mysterious center, also referred to as a singularity.
The singularity is problematic because it's almost as though things cease to exist, like they come to a finite end of space-time and they cease to be. And that's a kind of violation of the entire campaign of physics. Now, maybe that's true and that's what happens, but it violates the paradigm that we can predict the future from the past and the past from the future. That's in some sense knowability. That's what we mean when we do physics, what we're after.
Despite the unknowns we face with black holes, Einstein once said that the observable universe is knowable. He believed that everything within its bounds can in time be understood, and not just the present, but the past and future to come.
When people ask about extracting meaning from thinking about something as abstract as the origin of the universe or the death state of the universe, the meaning is in the fact that we can understand it. We've been around for a bleep in the history of the universe, a tiny, tiny bleep, and we're not looking that promising in terms of surviving into the millions of years the way the dinosaurs did. But what do we have that the dinosaurs didn't is we have this ability to know the universe. We have this ability to recognize that there was this phenomenon, the Big Bang, that our universe had an origin nearly 14 billion years ago, and that we're progeny of this complex cycle.
For decades now, black holes have taught us lessons in being wrong, about the importance of daring, and the need to think outside the box. You can broaden your own imagination and find out more about black holes and the universe by checking out Jana Levin's book, Black Hole Survival Guide, available online and in bookstores now. For more behind the scenes, search Viewpoints Radio on Twitter, Instagram, and Facebook. You can also learn more about all of our guests by visiting our website at viewpointsradio.org. This segment was written and produced by Polly Hansen. Our executive producer is Amira Zaveri. I'm Marty Peterson.
Viewpoints returns in just a moment.
Coming up next week.
They'll say, oh, I don't remember the eyebrows. Well, that means the eyebrows were boring. That means he didn't have thick, huge, Tom Selleck eyebrows.
The fascinating work of a police sketch artist. Then,
as someone who studies this, I find the rhetoric really quite disturbing. It's just people just tossing around the term treason very casually.
We speak with a legal scholar about the serious capital charge of treason. I'm Marty Peterson.
and I'm Gary Price. These stories in depth on your public affairs magazine, Viewpoints.